In today's notes, we're going to look at finding the domain and range for continuous and discrete functions, as well as determining if an equation is a function or not from an equation. So let's kind of look at the very first part of this page, which is the first 9 questions reviewing domain and range of continuous and discrete functions. So this is a concept you learned back in Algebra 1. So I'm going to go through this again, and for each of the questions, we're going to do the following. We're going to state the domain and range for each graph, and then tell if it is a function or not. We also will state if the function is discrete or continuous or neither. So for the very first question, this graph does not look like any of the other graphs on this page. For question number 1, this is a discrete graph. Discrete means that it's pretty much points. It's very similar to a scatter plot. So it's just points that are kind of all scattered throughout the entire coordinate plane. So to find the domain and range for this, a lot of students like this because all you need to do for discrete functions to determine the domain and range is to label out the ordered pairs that you have. So for each of these ordered pairs, I'm going to start with the far left one, and I'm going to write this out as a coordinate. So that's going to be -3, -4, and then I'll go to the next point, which is at 2, 5. And then the next one, which will be 1, 3. And the last one, or excuse me, not last one, the next one is 1, -2. And then the last one is 4, 0. Okay, so I have all my points labeled. And once you have them all labeled out, you want to write this out for your domain. So the domain is the set of functions or the set of values that are going to be -3, 2, 1, and 4. Whenever you have two x values or even y values that are the same exact number and those values are repeating, you do not need to write them more than one time. So just leave it as 1, 1, and move on to the next number. For the range is all of the y values. So every single y value that I have, I'm going to recopy as a set. So this kind of squiggle bracket that I have is your set notation. This is a 5, 3, -2, and 0. So that's my domain and my range. So my question to you is, thinking back to your basic concepts you learned back in Algebra 1, is this a function or not? Well, in order for this to be a function, it must pass the vertical line test. So that means if I was to draw a vertical line through every single point that's on this graph, specifically the black dots, will there only be one x value for every line? Well, for a couple of these, they look okay, but this middle one right here is kind of messing me up. If I was to draw a vertical line going straight through both of those points, it will hit at 2 separate places. So because of that, this is not a function. The remainder of these graphs are all continuous. So I'm going to write this out for a couple of them, but I'm not going to keep writing it out for every single question. The rest of these graphs are continuous. So continuous means that it pretty much doesn't look like a scatter plot. It doesn't look like these where the points are scattered all over the place. It's actually a shape or a curve or some kind of line. So I'm going to look at questions 2 and 4, and then I'll give you guys a couple questions to try on your own. So for question number 2, this is a continuous graph. And the first thing I want to identify is my domain. So the domain goes along the x-axis. So going along the x-axis means if I was to, and I always tell my students, start from the left-hand side of the graph for the domain and then go to the right. So starting at the far left side of the graph, it's going to keep going over here and it's going to start hitting right at this point. So this is the first part that it's going to hit. On the right-hand side, if we're going from the right, we're going to go until we hit this part right here. So we're just literally trying to run right into the sides of this graph. Okay, well, that's pretty much both edges of my graph. It's going from -3 to +3. So we're going to write our domain along the x-axis in interval notation. So in interval notation, we're going to start from -3 and go to +3. All I need to worry about now is if there are any open or closed circles along these edges that I have. So I'm just going to erase these for just a second, and I want you to take a look. Is there any open circles along here? Trust me, guys, if there was an open circle, you would see it just like this one right over here. But since I don't see an open circle, I'm going to safely assume that this is a closed circle here, and this is a closed circle here. So with closed circles at both edges of this figure, that means that my domain is going to have brackets at the very edge on both sides. Now let's look at the range. Okay, so for the range, we're going to look at the same exact graph. I'm going to use a different color. I'll use blue. And for this one, I'm going to start from the bottom of my graph to the top. So I told you guys before, domain goes from left and right. Range, I always tell my students to think of Drake. It starts at the bottom and then it's up here at the top. So if you start from the bottom of the graph, it's going to go up, up, up until it hits this large horizontal line. So I'm going to kind of do a horizontal line going this way. And then as I go from the top of the graph, I'm going to go down, down, down until I hit this top of the figure right here. Okay, well, let's talk about those numbers. The numbers are from -4 to +3. And remember, always think of Drake. Started from the bottom, now you're here at the top. So especially for my range, I'm going to go from -4 to +3. And again, we need to figure out, are there any open circles or closed circles at this point and this point? Okay, well, you really don't need to erase them, but I will. Down here at the very bottom, there's no open circles, guys. If you see an open circle, trust me, it would look just like this. So at the very bottom for -4, I'm going to put a bracket for a closed circle. And then at the very top of the graph, same thing. This is actually a point, and that point is closed. If it was open up here, you would definitely see it. So I'm going to put a bracket. The last thing I need to identify is the range, or not the range, excuse me, if it's a function or not. So if it's a function, I want to see if it passes the vertical line test. So vertical line means if I literally draw a vertical line anywhere throughout that graph, it should only hit it one time. Okay, well, so far I'm good. It only hits one time. But we already know I'm kind of avoiding the obvious. If I go straight down the middle of the graph, it's going to hit at 2 places. So unfortunately for us, this is not a function. Let's look at example number 4, and then I'll have you guys try a few on your own. As we said before, for example 4, this graph is continuous. Okay, well, since it's continuous, let's go ahead and try to find that domain. Okay, so the domain here is a little different. For the domain, I'm going to start from the left-hand side, and I'm going to keep going, 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 and the first thing I hit is right down here. It's this arrow. Okay, well, let me think about this for a second. If I'm going to hit this arrow, is it going to stop at this point? No, it's not going to. This arrow means that it's going to keep going. So instead of drawing it as a boundary like I did for our 5-sided figure up here, I'm actually just going to circle that arrow. That circle is going to be a little reminder to me that, hey, Miss Tapia, you need to make sure you remember that it's not going to stop here. It's actually going to keep going all the way off of this page. Let's do the same thing, but going from the right. As I go from the right-hand side, it looks like I'm going to run into this first, but before I can get to it, I run into this arrow. So again, I have 2 arrows on either side, and both of those arrows mean it's going to keep going down here to the left, so over here along the x-axis, and it's also going to keep going up here to the right, which is going this way on the x-axis, to the right-hand side. Well, what does that mean for your domain? That means that your domain has to go from -infinity to +infinity. And remember, we talked about this in our interval notation notes. Whenever you're going from infinity and -infinity, you always want to put a parentheses. And then always also remember to put the -infinity first and then the +infinity. You're always reading these notations from left to right, or in this case for range, like we're about to do in blue, from bottom to top. So starting at the bottom of your graph, we're going to go up, up, up. And even though I would love to skip over this arrow, I can't. As you go up, the first thing you're going to run into is this arrow. So in blue, I'm going to circle this arrow. And then as you go from the top of the graph as well, going from the top, the first thing I'm going to run into is this arrow right up here. Well, we're having that same situation. It's not going to stop at either of those places at the bottom of the graph nor the top of the graph. It's not going to stop anywhere. It's going to keep going down the y-axis and up the y-axis. So that means we're going to go from, for our range, -infinity to positive. And then my last question is, do we know if this is a function or not? Well, vertical line test represents a function. So I'm going to check here. It only hits one time. And check here. That only hits one time. Check here. That only hits one time. I think no matter, I can keep doing this forever, but I don't think we're going to find a way to hit this graph more than once, at least doing the vertical line test. So is this a function? Yes, this is a function. So right now, what I want you to do is I want you to pause the video and I want you to try, let me zoom out a bit. I want you to try questions 3, 5, and 6. So right now, pause the video and do questions 3, 5, and 6. Okay, let's look at number 3. So for question 3, I'm going to go through this in a little detail just because I know it's a little different. But for question 3, the first thing we're going to do is we're going to see if it will, what the domain will be. So we already know that this is supposed to be continuous. Even though these circles are clearly visible, it's not going to change the fact that this is a continuous function. So in red, I'm going to go ahead and do the same thing I did from before. From the far left-hand side, the first thing you run into is this value over here at -4. And as you go to the right-hand side, you're going to run into this arrow first. Okay, so we're going to write this out from left to right. On the left-hand side, we're going to start from -4, and it's going to go all the way to positive infinity. Positive infinity for sure has to have a parentheses behind it. You can't change that. -4 though, since this is an open circle, we're going to have to put a parentheses, not a bracket, a parentheses around this. If this circle was filled in, then I would definitely put a bracket here. But since this is an open circle, I'm going to leave it as a parentheses. For the range goes from the bottom of the graph to the top. So starting at the bottom of the graph, you should have run into +1 first. And then at the top of the graph, you're actually going to run into this arrow because this arrow, we've already talked about this, is going to keep going all the way towards infinity. So since we're looking at the range, we're going to start from the bottom of the graph, which is 1, and it's going to go all the way up to positive infinity. Well, we talked about this before. Positive infinity should have a parentheses behind it every single time. 1, however, in this case, since 1 is along this little horizontal line here, there's 2 closed circles here. I don't see an open circle along here. So it looks like, especially since there's 2 closed circles, that it's going to be a closed included value. And then the last piece is the function. Is this a function or not? Okay, well, let's draw some vertical lines throughout this graph. I don't see any of these lines hitting the graph more than once, so yes, this will be a function, even though we have some open circles. Let's go ahead and look at number 5. So for number 5, the domain, again, you're going to start from the far left of this graph. This is a continuous function. So starting from the far left-hand side, we're going to start from -infinity. And we're going to go all the way over here to 4, which is going to be a closed circle. The range for this, you're going to start from the bottom of the graph. Be careful here. You're probably looking at this blue line like, wait, Ms. Tapia, this doesn't touch the y-axis. Yes, it does. This blue line is touching the y-axis, well, where the point is, it's technically touching the y-axis at 0. So it's going from 0, and the very top of the graph is right up here. Okay, well, the top of the graph isn't really the top. It's going to keep going. So that's going to go to positive infinity. Again, anytime we have an infinity, we have to put parentheses behind it. The 0, though, at the very end, all the way down here, that's a closed circle. That's closed. So we're going to put a bracket. And then the last thing is this a function? Yes, this is a function. This last question is one of my favorites because it's kind of easy. So domain, start from the left and go to the right. Starting from the left-hand side, going to the right-hand side, you're not ending at any specific value. So we're going from -infinity to positive. The range is starting down here, and this is at 0. And let me actually go back and put this was 0, this was 4, and yeah, I already did that for this one. So I just wanted to add that in because I forgot to put the values. Okay, so we are starting down here at 0, and the range is going up here at the top. Well, I have 2 arrows at the top of this graph, and both of those arrows are going to keep going up the y-axis. So it's going to keep getting more positive, bigger, larger numbers. So we're going to go from 0 to infinity. At 0, okay, at the very bottom of this graph, if there would be 2 open circles, then I would definitely put a parentheses here. But since there's no open circle, we're just going to put a bracket behind it. And is this a function? Yes, this is a function. All right, the remainder of these questions can be used as extra practice. So even though I'm not going to go through them, especially number 8 on this page, number 8 on this page right here, this is a really good question to try. So if you have some time, definitely try this problem. All right, let's look at the last bit of notes, which are going to determine if an equation is a function or not. Okay, well, I know you're thinking, oh my gosh, Ms. Tapia, I don't know how to graph all of these things. Okay, well, don't worry. We're going to go through this together. So whenever you're looking at these questions, there's really just 2 steps that I want you to follow. And I actually want you to write these steps out. So whenever you're looking at finding if a equation is a function or not, the first step that I want you to do is to solve for y. That's the first thing I want you to do. Solve for y. The next thing that I want you to do is I want you to plug in a number. It doesn't matter what the number is. So plug in a number. I recommend a number that's not quite 0, but maybe a little bigger, like, I don't know, 3 or 4 or 5, something like that. My favorite number, fun fact about Ms. Tapia, my favorite number is 4. So I'm going to use for all of these questions x equals 4 to find out if this is going to be a function or not. And the way I'm going to do that, once I plug in a number, I want to see if there's going to be 2 outputs. So I want to see if there's going to be 2 outputs. What that's going to do is tell us if this is going to be a function or not. So let's go ahead and look at the first question. So for question number 10, luckily for us, the first step is done. It's already solved for y, so I don't need to worry about solving for y. What I do need to do now is plug in a number. You don't have to use my number, but I wouldn't recommend using 0 because sometimes 0 doesn't show you enough of the function. So if I were you, I'm going to use x equals 4, and I'm going to substitute it in. So y is going to equal 4 squared minus 9. Okay, well, 4 squared is going to be 16, and 16 minus 9 is just 7. Notice that I only have one value. Okay, well, this is a good thing. That means that question number 10 is a function. That's my answer. Let's look at question 11. That's all we're doing, guys. Once you have y isolated, you're just plugging in a number and simplifying. For number 11, we're going to do the same thing. For this question, though, I do actually need to solve. So let me rewrite this. Y squared equals 9x. I'm going to square root both sides. So y is going to equal the square root of 9x. And I can technically take the square root of 9, but I don't really need to here because technically by writing this, I forgot something. What did I forget here? If you forget to put this plus or minus, guys, we've had this conversation before. I have pre-cal students who still forget to put this plus and minus. Whenever you plug these values in, please make sure that you actually plug in a positive and negative. So that way you can see that there's going to be 2 possible solutions. So I kind of just answered the question that I was going to ask. If I was to plug in 4 for my x value, would I get 2 solutions? Well, by having this little plus and minus here, that should answer your question. There's going to be 2 solutions because of that plus and minus. If you don't believe me, plug in 4. Take the square root of it, and you should get a positive and negative of whatever that is going to be when you multiply it. So down here, I'm going to put that this is not a function. That's all you're doing. 2 quick steps. I'm going to look at a few more questions, and then I'll give you a couple to try, and then we'll be done. So for question number 12, I'm going to scroll down and look at question number 12. Okay, first thing I need to do is isolate my y. I need to solve for y. Okay, well, in order to solve for y, there's 2 of them. Okay, well, hopefully I'll remember. We've been talking about this for days. We're going to have to factor that out. X cubed minus 2 is going to equal 6. Which means I'll be able to divide x cubed minus 2 on each side. So y is going to equal 6 over x cubed minus 2. and this will be my equation solved. Okay, well, I have that part done. Let's go ahead and try to figure out if this is going to be a function or not. So using x equals 4, I'm going to substitute that in. Hopefully y'all remember, we're just using order of operations. So 6 over 4 cubed is 4 times 4 times 4. Well, 4 times 4 is 16. 16 times 4 is going to be 64 minus 2. And 64 minus 2 is going to give me 6 over 62. That's only one value. So it's looking promising. For example 12, this is a function. For number 13, same process. We're going to need to simplify it a bit. And for question number 12, before I forget, you can technically simplify this. So let me actually take it a little bit back. We can actually simplify this. 6 over 62, if you divide that, I forgot you can reduce. This will give me 3 over 31. It doesn't affect the fact that it's still going to be a function because there's only one solution. It just so happens that that one solution we can simplify, but it doesn't change the fact that it's still a function. Okay, moving on. Let's look at example 13. For example 13, we're going to isolate y. Okay, well, it's already isolated. Let's take x equals 4 and substitute it in. So y is going to equal the absolute value of 4 minus 3. Okay, well, 4 minus 3 is just the absolute value of 1. And the absolute value of 1 is just 1. Okay, well, I have to think about that. Is that going to mean that I'll have a function? Well, I only got out one value. So this guy here is also a function. Number 14 is a little different. For number 14, this one is already having your y value isolated, which is good, but that absolute value is really throwing me off. Okay, so let's just take x equals 4 and substitute it in. So the absolute value of y is going to equal 4 plus 1. Okay, so 4 plus 1 is the absolute value of y, and 4 plus 1 is 5. Is this going to be a function? Okay, well, let me refresh your memory with something. Whenever you're taking the absolute value of a number, that means that y can either be a positive or it can be a negative. Because think about it. If I plug in negative 5 here, the absolute value of negative 5 is just 5. Same thing if I plug in positive 5. The absolute value of positive 5 is just 5. So for this question, unfortunately, this is not a function. So I'm going to have to write it down here. This is not a function. And I know you're looking at this like, wait, Ms. Tapia, this doesn't make sense. How is this one not a function, but the last question was? Here's why. In this problem, y was your unknown. When you were solving for y, you pretty much had to take whatever x was, substitute it in, and simplify. This value, whenever you plug it in, it's already your positive or negative. So when you take the absolute value, for instance, of this positive 1, you can only get out a positive value. If I had a negative 4 in here and I had negative 7, again, the absolute value of negative 7 is just 7. You can't get two possibilities when you're taking the absolute value. The reason why this one is not a function is because when you have this y, it can either be one of these two signs. So be careful with how you're looking at these. Depending on where your absolute value is, it could completely change your problem, completely. So with all this in mind, I've done a few with you. I want you guys to try to do a few on your own. Right now, I want you guys to do numbers 18, 16, and 20. So do numbers 18, 16, and 20. Pause the video right now and try numbers 18, 16, and 20. All right, let's start simple. For question 16, the first step you should have done was solve for y. So this one's simple. You have xy equals 12. We're going to divide both sides by x. So y will equal 12 over x. That's the first step. The second step is to plug in a number and see if you get two outputs or two values for your solution. So let's do that again with x equals 4. So with x equals 4, I'm going to substitute it in. Y will equal 12 over 4. Well, 12 over 4 just reduces to 3. That's only one answer. So that means that question number 16 is a function. Let's check question 18. For question 18, I'm going to zoom in. I need to isolate y. So the first thing we should have done was subtracted the x minus 3 squared on each side. You don't need a FOIL. So we're going to be left with y squared equals negative x minus 3 squared plus 4. And we still have this squared on your y. Well, the opposite of squaring is square rooting. So we're going to have y equals the square root of negative x minus 3 squared plus 4. When you're square rooting something that's squared, please don't forget that when you're square rooting, especially both sides of an equation, you have to put that plus and minus. You have to. That's going to tell you that there's going to be two solutions, which in turn means that there's going to be no function here. For the last question, for number 20, okay, again, I need to isolate y. Okay, well, let's try to work this out. In order to isolate y, first thing I'm going to have to do is square both sides. Hopefully you guys agree with that. So we're going to have the 2y minus 4 outside of your radical because the square root and squared cancel, and I'm going to have x squared on the right-hand side. From here, it's a very simple problem. You're just going to add 4 to each side. So 2y will equal x squared plus 4, and then I'll divide everything by 2. Okay, so that's my equation solved for y. Now I need to check to see if x equals 4 is going to be a solution, and if it's really just going to be one solution. So y will equal 4 squared plus 4, not 14, all over 2. 4 squared is 16. And when I add 16 and 4, that's going to give me 20 over 2. 20 over 2 just simplifies to 10. So is this a function? Well, it only gave me one y value, or really just one value. So this is a function. That means that that will not have any x's or any y values that repeat. So whenever you have two y values like we saw before, that's when you're not going to have a function. If you solve the problem and you just get one solution like we saw here, you're going to get a function. It's very simple. So my favorite part about these, whenever you're trying to figure out if these are a function or not, is you no longer need to worry about trying to look at the graph. So whenever you're trying to determine, again, if this is a function or not, make sure don't try to graph it, solve for y, and then pick a number to plug in. You aren't required to pick 4, but pick a number that's not quite 0, 1, or even 2. I'd pick a higher number. I wouldn't go as far as 10, though, because 10 is just a little obnoxious. If you have any questions over this or if you have any concerns, please let me know. But in the meantime, make sure you practice with the questions we haven't done.